You are welcome to today's GMAT class. The question we have to treat is very interesting. So let's just go ahead and take a look at it. How many positive integers less than 1000 are multiples of 5 but not of 4 or 7? So we are asked to find the multiples of 5 and then that are less than 1000. From that list, we remove the multiples of 4 or 7. Now, this looks like a question where you need to list items. If you go on that route, it will end up an absolute nightmare. So the best approach for this kind of problem is using set theory. So, but before we go ahead and start solving the question, we need to take care of a few things. Now, what does the word 4 or 7 mean? Under sets, 4 or 7 or 4 and 7. So that is what that means. So we are going to, from the list of multiples of 5 less than 1000, we are going to remove the multiples of 4, multiples of 7, multiples of 4 and 7. So, but first, let's draw a diagram, a Venn diagram. Since when you are dealing with sets, the Venn diagram is very important in some cases. So let's call this A, and A is all the element. It is a universal set and contains all the multiples of 5 greater than 1 but less than 1000, because how many positive integers? So we are looking at between 1 and 1000. Take note, multiples of 5 less than 1000. Then from that list we remove, so there is an imaginary b here, so imaginary 7. So these are the subsets we need to take away from the list. So multiples of 4. So numbers among the list that are divisible by 4, 7, or 4 and 7. So let's create the formula first. So here we have the A. From A we need to remove, so there's an imaginary B here that encircles 4. So let's say we have A intersection B. We need to remove that. We have it once. We have it once in A, so we need to remove it once. Then there's an imaginary C here that covers 7. So we remove A intersection C. Now, let's now look at A intersection B intersection C. Remember the other part, I want you to just follow the explanation. I'm talking about A, B, and C here to make the calculation much easier. So if you extend this, if you extend for this circle, you generate a B here. If you extend 7, you generate a C here. Okay, so now for A intersection B intersection C is this region, this particular region. Now we have it listed in A once. We removed it in A intersection B, removed it in A intersection C. So that means we have it one, removed it twice. We don't need it at all. So we add this A intersection B, intersection C. So this is the diagram from which this one was formed. So this, so to reduce any kind of confusion. So this is A, this is B, so this is C. So we scrap this out from these three rings and then brought this one out because this is the only one we need. Okay, so now this is A minus A intersection B. This one becomes A minus A intersection B plus A intersection C, then plus A intersection B intersection C. So now let's begin to plug in the items. How many multiples of 5 are greater than 1 and less than 1000? So remember, 1000 is a multiple of 5. We don't need it in the list. So to calculate number of multiples of a number from another number, you divide it by the number. So this divided by 5. So this gives us 200. Remember, among these 200 items, we have multiples of 1000, so we remove 1. So this becomes 199. Now, A intersection B. A intersection B means multiples of 4. But we are not talking about multiples of 4. We are talking about among the multiples of 5, the ones that are divisible by 4. So that means we look for the LCM of 4 and 5 and generate that list. So that is 20. So we are talking about multiples of 20 in 1000. Remember again, 1000 is a multiple of 20. So we need to remember to remove 1000 from the list. So how many multiples of 20 do we have in 1000? That is 50. We remove 1, less than. So we remove 1, so we have 49 here. So we move on to A intersection C, that is 7. How many multiples of 7? Among the multiples of 5, how many of them are divisible by 7? So we find LCM of 5 and 7, that is 35. So how many multiples of 35 are less than 1000? So now, in this case, 1000 is not a multiple of 35. So whatever value we have is what we just use directly. So 5 here is 200. 5 here is 7. So let's erase some items here to create space for. Okay, so we have 200 divided by 7. So how many 7 do we have in 20? That is 2. 2 times 7, that is 14. So we have 6, bring down 0. How many 7 do we have in 60? That is 8. 8 times 7, that should be 56. 60 minus 56, that is 4. There is no number to bring down, so we are going to have a decimal part here. So we don't need decimal part. So that means we have 28 multiples of 35 between 1 and 1000. That is many. So we come here. Once again, erase this part. So we are now looking at the multiples of 4, 7, 5. So the first one is to find the LCM of 4, 7, 5. There are no factors between them, so we just multiply everything. That gives us 35 times 4, that is 140. So how many multiples of 140 are between 1 and 1000? 1000 is not a multiple of 140. So you can just work on it directly. So this cancels. 2 here is 50. 2 here is 7. So we have 7 of them. This is 7. So 49 plus 28, that is 7 is 77. So this is 199 minus 77 plus 7. So this is 199 plus 7 minus 77. So we can just say 7 minus 7, that is minus 70. So 199 minus 70. So that is 9, 129. So our answer is 129. So that makes the whole thing a lot more easier. So that is all for today. If you like what you have seen, you can go ahead and like my channel. Drop a comment if you want. Subscribe to the channel to see more of videos like this, and then so that we can have a lot more classes together. Yeah, so that is all for today. Until when we meet some other time. So bye bye.